developing world. All right. So next, let's multiply and divide rational expressions. We've done this before. We've multiplied and divided fractions before. We know there's only a couple things you got to know to multiply or divide fractions. Multiplication is easy. It's top times top over bottom times bottom. And as I taught you, you want to arbum, reduce, before you multiply. And so that's the idea. So this is just AC, and this is BD. And that's been on every test since the beginning of the year. And unfortunately, some of you still occasionally mix up your multiplication and your division. But for the most part, you guys have it down, and that's fine. However, in this chapter, the arbum is going to be an issue. So back when we were dealing with just numbers and simplistic variables, some of you didn't reduce before you multiplied. And you didn't think it was any big deal. It's a really big deal, this chapter, because now you end up with a mess. And it's very time consuming. Not only will you almost never get back to the simplified answer, now you're taking way more time than you should because you're multiplying things out and you're not even going to be close to the answer, and it's not going to be a minor deduction. So if you go ahead and if you don't reduce before you multiply, you're going to get the whole problem wrong, not a minor deduction for not reducing. Because the whole point is to get the simplified version. So make sure that you reduce before you multiply. You got to reduce before you multiply. You got to reduce. So again, always look to reduce. That should be read before you multiply. All right, I don't know how much I could say it. I don't know how much I can emphasize it so it's clear. If you never look back at your notes, you'll never see it again. But if you look back at your notes, you should see it. So here's a pretty simplistic one. Now, take note of what we have. This is important. The top left is a monomial. It's one term. The top right is a monomial, one term. The bottom left is a monomial, one term. And the bottom right is a monomial, one term. Remember, terms are separated by addition or subtraction. We already learned what a monomial is, what a binomial is, what a trinomial is, what a polynomial is. With monomials and them all being monomials, anything can reduce with anything, top and bottom. It's all ready to go. But when you have binomials and trinomials and polynomials, it's a different story. I'll talk about that on the next example, but you have to be able to distinguish. This has to be your first thought. You have to say to yourself, oh good, I've got all monomials, everything's ready to reduce. And that's what you're after. So that's the thought and that's the concept. Let's play with the numbers first. Come on, Windows. So I'm looking at my 15 here, and that's a 3 and a 5. And you already see the 3 on the top left and the 3 on the bottom right, right? And they're gone, right? Those 3s are gone, gone, and gone. Yes, my 3s are gone. And I got this 10 up here, and that's a 2 times 5. And again, as long as something's on the top and you got the same thing on the bottom, anything divided by itself is 1, and so now I'm dividing out the 5s. They're gone. And I see this 4 over here, and I can take care of one of the 2's on the bottom with that 2 on the top. And now I'm left with a lonely 2 in the bottom left. But that's it. No more numbers left, right? Now I'm going to start working on my variables. I have an x squared, and I have an x. Now again, most people understand if there's 2 on the top and 1 on the bottom, that leaves you what? 1 on the top. Now if you can't do that, then make the top x times x and cross off the common x's top and bottom. That's the idea. Let's go to our y's. I'm going to do it in green. I got a y cubed, and I got a y to the 5th. So I have 3 on the top, 5 on the bottom. So what does that leave? How many of them and where? So y squared on the bottom, right? Exactly. So 3 on the top, wipe out 3 of the 5 on the bottom, leaving you 2 more on the bottom. Okay, those are gone. And our a's are going to go away, right? Because we have an a on the top and an a on the bottom. And that's all the simplifying, right? That's all that was R-bum. Now we're ready to multiply top times top. And the only thing left on the top is an x. There's not even anything left to multiply. And the bottom we have a 2 times y squared, and that's a 2y squared. And that's the answer. And it was really all about reducing. It's all about simplifying. That's what it was all about. Okay? But again, monomial, 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 monomial. That's the key on that one. Let's go to the next one. So now top left is a binomial. Bottom left is a trinomial. Top right is a binomial. Bottom right is a binomial. We cannot do what we just did. Do you hear me? And yet every year students try to do what we just did. You can't. Watch, don't do this. They'll do something like this. Oh, cool. -1, -1, gone. Why can't we do that? Because they're tied together, right? The binomial is the binomial, and x minus 1 is the -1 is tied into the x. You cannot do that. Don't 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 do that. You can't do that with these x's. You can't go, oh, cool, x squared over x squared, they're gone. You can't do that. It's a trinomial. It's a binomial on the right and a trinomial on the bottom left. You can't do that. I can't. Not true. They're tied together by the fact that it's a binomial, by the fact that it's a trinomial. You can't do that. So be careful. So it's all about factoring. So we got to factor this, this, and this. So that's what I want you to do. Go ahead and factor top right, bottom left, bottom right, and then see if anything divides out taking the whole factor. As you're going, you could look up here if you need to for any help. Okay, I saved that bottom right because you looked at that and hopefully said, oh, that's a difference 2 squares. Plus in the middle of one, minus in the middle of the other. Square root of the first, square root of the last, right? Difference 2 squares. Hopefully you haven't forgotten what a difference 2 squares is. Now I'm going to look for common terms. Okay, this whole x minus 4 and that whole x minus 4 is gone. And I can do this x minus 1 and this x minus 1, and that's gone. And that's it. I can't do that x with an x plus 1 on the bottom. If I had an x factored out on the bottom, I could have, but I can't. Top's going to stay an x. If I want the best answer, this is what my bottom's going to say. X plus 1 quantity squared, right? This is weird, and I know this is strange, but we actually don't bother to multiply out the bottoms. We leave them in factored form. Say, Mr. Scarfi, that doesn't make sense. And you're right, it doesn't make sense. It's a multiplication problem, Mr. Scarfi. We're not going to multiply it out. No. Because here's the problem. We're trying to teach students a process, and we're trying to teach you what you have to do to get to be able to multiply polynomials, rational polynomials. And it takes time. You got to do a lot of factoring, then you got to do reducing. We assume you already know how to multiply those 2 binomials out. We just have to assume that, because if we also cause you to take the time to finish it, now that's less time to see if you know other stuff. So we're going to leave it factored only because of time's sake. Only because of time. Technically, the answer would be x over x squared plus 2x plus 1 if we multiplied those 2 binomials out in the bottom. And that would be technically what you should do. But we're not going to do that for time's sake. So for what sake? Time's sake, because it's time consuming, and we need to make sure you understand all the other concepts this chapter, Lauren.
Can you not take the x plus 1 out because they're both in the bottom?
Yeah, they're both in the bottom, right? So there's nothing to divide out there because both are in the bottom. Always got to be one top, one bottom. All right, good question. Anybody else on that one? Okay, and so you can't be done already. Like 10 minutes? All right, you did well. All right. That was really fast, Abby. Really, 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 really fast. All right, but hope you did well. So you could see that, I mean, they could begin to get complex and long. So now we have three things. Now, again, you got trinomial left on the top. Middle top is two binomials. Hey, look at that middle one, Earth to daydreamers, Earth to people that aren't interested, Earth to people that won't know what to do later on. Two binomials. That thing is already factored. We did some of the work for you. We're saving you some time. All right? Top right, a monomial, we got a 1. Bottom left, just one term, binomial. Bottom middle is a binomial. And then we got a factor. So we only got to factor top left, top bottom, and divide out common factors. Go ahead and do that. Factor top left, top bottom, divide out common factors. Leave your answer in factored form. Oh, 15, 3, and 5. I need the 5 to be negative and the 3 to be positive. Six, and 1. Need the 6 to be negative and the 1 to be positive. All right. X plus 3, none. Oh, bummer. X minus 5, none. Come on. All right. X minus 6, we got one of those. X plus 2, we got one of those. That's it. This thing's going to stay x plus 3 times x minus 5 over x minus 3's got to go in a parentheses, right? Times an x plus 1 because it's whole denominator times whole denominator. So though the x minus 3 didn't have a parentheses to begin with, when you're going to write your answer, we're going to put it in parentheses. Again, technically this isn't a final answer, but for our sake and for time, we're going to leave it factored for time's sake. How many got that correct? And again, factoring, factoring, factoring. Now, any questions on the factoring? Anybody want me to review the thoughts in the factoring? All right, can't help you if you don't tell me you're sick. All right, number 3. So dividing. So again, most of you remember that division, you change the division symbol to a multiplication symbol, and you invert the second fraction. So the D goes from bottom to top, and the C goes from top to bottom. Once you're at the multiplication step, you want to arbum, right? Reduce before you multiply, right? Reduce before you multiply. So again, what is division? Invert the divisor and multiply. The divisor is the whole second fraction. The dividend is the first. Okay, so let me real quick try to refresh your memory on why this shortcut rule works. All right, so why does A over B divided by C over D? Why does it work? It's the same as this format, right? And if you had a problem like that, hopefully that's not going to scare you. These two are exactly the same, right? Exactly the same. An A over B divided by a C over D. They're exactly the same thing. Oh, Windows. So how am I going to solve this? I could put it in the other format, but I want to show you why it works. So technically, what would we do? With this compound fraction, we got to get rid of the denominator. I'm going to make the bottom a 1. How can I make the bottom a 1? If I multiply it by a D over C. That's going to make that whole bottom a 1. Because we don't like to have a fraction over a fraction. That's no good. Now, do you agree that that makes the bottom a 1? Because everything's going to divide out. But I just changed the value. So in order to not change the value, what I do to the bottom, I have to, same thing to the top, right? So again, I'm going to do the exact same thing to the top. I'm going to do D over C. So again, you can notice all the bottom is gone, and what's left on the top? You inverted the second one and you multiplied, right? Isn't that what happened? I inverted the second fraction, and now it's multiplication. So again, look where we started here. I showed you the format of the A over B divided by the C over D. When I multiplied the bottom to get it to be a 1 and did the same thing to the top, notice we ended up at the rule, right? And again, that's why the rule is the rule. So the rule is just a shortcut for doing that. When we get into complex fractions down the road in this chapter, we'll need to do some of this, and we'll deal with that when we get there. Okay, so anyhow, how can we get the denominator to be 1 was the whole concept there of what I just did. Let's do a couple examples. All right, the biggest thing you got to be careful of is don't try to reduce anything until you're on the multiplication step. Don't try to reduce anything until you're on the multiplication step. Most students like to factor it first and then flip it. Others like to flip it first and then factor it. Whichever way is going to make you not forget to flip and multiply. So I think most think it's safer to change the division to multiplication and to flip it right away. That does make it so that when you factor it, you are ready to reduce. That's probably the better way. But again, it doesn't matter as long as you make sure that you don't reduce until you're on the step of multiplication. All right, so before we go any further, just pause with me for a second and think about something. Top left, trinomial. Top right, monomial. Bottom left, monomial. Bottom right, trinomial. We can reduce those two monomials, just like we did the monomials earlier in the multiplication section. So right away, we can make this an x squared in the bottom. Do you agree? Because they're monomials. They're one term. Remember, you can reduce a one term with a one term. Okay, go ahead and finish factoring everything, and then reduce. Go ahead and factor and reduce. And again, we're going to leave it in factored form when we're all done. If you're stuck factoring, you can look up here. Again, you got to make sure your outers plus your inners equals the middle. Outers plus the inners equals the middle. And again, your two last terms have to multiply to the last term. Whoops. And again, that's what you're always thinking. All right, reduce it to finish it out. Those are gone. And that's it. What is my top? X plus 2. What is my bottom? X squared times x minus 2. Now look, if you multiply that out, because it's a quick one, I'll take that answer, not a problem. We're just not multiplying them for time's sake. That would be x cubed minus 2x squared, would be pretty simplistic, and I would obviously take that answer. But again, for time's sake, we'll just leave it factored. So again, we're going to factor top, factor anything in the bottom, and reduce on the multiplication step only. Any questions on that? Questions? Okay, try B then. Go ahead and do B. So again, you're factoring. I like to change it to multiplication and invert it before I factor, and then I'm ready to reduce. Oh, let's see. What do I got? An x minus 3 and an x minus 3. And what else? Is that going to be? No, I have an x plus 4 and an x plus 4. Is that it? I think that is it. 4 and 3, yep. 8 and 3 is 11, yep. Close, but no reduction. So the whole x minus 2, 2x minus 3 stays. And you got an x plus 3 and a 2x plus 3. Close, but that stays. And again, for time's sake, you can see that's a whole lot longer if you're going to multiply all that out. Questions? How many got that correct? Okay, and the rest of you are still struggling with your factoring, so you better talk to me. Come on, talk to me. What are you missing on this? What are you getting wrong? Where do you need help? Caitlin?
I got an extra x plus 4 on the top.
An extra x plus 4 on the top. Okay, so you did factor x squared plus x minus 12, right? Did you get an x minus 3x plus 4? Did you reduce that x plus 4 with an x plus 4 from the bottom? So maybe your bottom factoring, did you get 2x plus 3, x plus 4 on the bottom? And that's why you would have that extra x plus 4 on the top. Let me refresh your guys' memory. Remember, when you have a coefficient with your variable 2x, when you multiply your outers, that's an 8x. And again, it's all about the outers plus the inners equaling the middle. You should know whether you got these. That's how you factor. You know you got to add up to positive 12, and you got to make sure your outers plus your inners equals the positive 11x. That's what you're looking for. Difference of two squares, that one you had to remember. 2 parentheses plus the middle one minus the middle one the other, square root of the first, square root of the last. Okay, one more. Some more factoring practice. You can see that's what this whole thing is about. Go ahead and try to do C. Do C. Okay, I need everybody to pause. Now, I'm going to go back to chapter 10, first lesson. I want everybody to look up here. Because again, most of you still struggle with the very first thing that we learned to do in how to factoring, and that is factor out common factors. And some of you better go back to this chapter, chapter 10, and you better go back and look at lesson 1. And you better go back and you better go watch the video again. Because some of you still struggle with factoring out common factors. But more than that, you may understand how to do the factors, but you miss the fact that the first thing that I taught you in factoring is to always do this. So once we started factoring everything other than just taking out common factors, that's what we had in our notes. And I said to you, every polynomial doesn't have them, but you must look. And I've said it every single time since. And yet, for some reason, you guys can't get there. So you got to do something to get there. And I'm hoping that me showing that to you again gets you there. So again, when I change this to multiplication, and when I put the top on the bottom, and the bottom on the top, I now say to myself, I'm ready to factor. I like to be orderly, so I'm going to start on the top left. And I'm going to say to myself, the first thing I'm going to look for is to factor out common factors, like the 2x. And half of you didn't have the 2x factored out. So that's a 3x minus 1. That's factored. When I come over to the top right, trinomial, I got to do 2x and x. I have a 5 to work with, so 5 and 1, and I got to end up with a negative 9 in the middle. How about a negative 5? That gives me a negative 10 on the outers and a positive 1 on the inners, which gives me that negative 9x in the middle. That's the factoring of that. I look at the bottom right and I say, oh, here's another one. Factor out the common 8s. 3x minus 1. And now I'm ready to finish it off. 3x minus 1, 3x minus 1. And that's going to be it. Unfortunately, the top right is a minus 5 and the bottom left is a plus 5. I have a 2. Oh, I do have a number I can deal with. So I've got a 2 here and an 8 here, and I can divide out the 2's. That is it. What's left on the top? An x, a 2x plus 1, and x minus 5. Now you see why we leave them factored for time's sake. On the bottom, best to put the number first, the 4. I have an x plus 5. Is that it? That's all I have, isn't it? A 4 and an x plus 5. How many got that correct? And again, factoring. You're going to have to practice tonight. Factor, factor, factor.